My name is Dave Eddington. I'm an assistant professor in the Department of Bioengineering at the University of Illinois at Chicago. And the area we work on primarily is applying microtechnologies to biomedical applications, specifically using microfluidic devices. And today we're going to show you one of our projects which involves using a microfluidic device that adapts to a standard brain slice perfusion chamber to provide spatiotemporal stimulation of a brain slice. So currently in electrophysiology slice preparations, the main applications of neurotransmitters to a slice are either globally across the entire brain slice, where you're stimulating the whole brain slice at one time, or using a micropipette to puff on neurotransmitters at different time points. The brain slice is a very complex structure, and when you're globally applying neurotransmitters or using a micropipette, you cannot reproduce in vivo stimulation patterns, whereas with our platform, we're able to control the stimulation to very specific regions across the brain slice and achieve a more in vivo-like stimulation. So current perfusion systems are shown here where they dock with a standard cover glass slide, and these allow for the media to be perfused across the entire slice. However, you can't spatially control the resolution of that neurotransmitter that you're stimulating the device with. So we developed a microfluidic device that docks with this standard perfusion chamber, so all the standard electrophysiology assays can be used. And the only